Hello friends, we will be taking up arithmetic progression in this session. So friends, now let's try to understand what are sequences. You must have observed certain numbers, letters, pictures, shapes arranged in a specific way. Now an arrangement of numbers in an order like A1, A2, A3 till AN forms a sequence. Now the nth term of the sequence is called the general term of the sequence. So in this case, when we say an, that is the nth term of the sequence, and that is also called the general term. Now in sequence, say for we were taking a sequence 1, 3, 5, 7, 9, 11 and so on, we can say that the first term, which means A1 is 1, A2 is 3, A3 is 5. So A1, A2, A3 are representing the first term, second term, third term and so on. Now let's understand what are progressions. Those sequences whose terms follow a specific pattern. It has certain pattern between the different terms. Then it is called a progression. For example, 1, 3, 5, 7, 9, 11, 1, 2, 4, 4, 8, 16, 32. 1, 4, 9, 16, 25, 36, 49. So let's see what is that certain pattern. Now that pattern is not the same in these three progressions that we've written here, but there's a certain pattern between the first term and the second term. So here we see that each term is incremented by 2. 1, 3, 5, 7, 9, or you could say that this is a progression with all odd numbers. And if you look at this progression, it contains all the terms with 2 to the power something. So it starts with 2 to the power 0, then 2 power 1, then 2 to the power 2 and so on. So this is a progression which follows this pattern. And then we have 149. This shows that it is a square number, 1 square. Then the second term is 2 square. The third term is 3 square and so on. So the sequence has the terms which are following a certain pattern. So these are called progressions. And this we've seen that these are very common type of things in the mental ability questions. And obviously we see certain patterns at other places like steps of a staircase, the pocket money rise, salary rise and things like that. So these kind of things are quite common, the progressions. If we are able to make a pattern when we have these progressions, or we can say if we have a sequence where we are able to make a pattern, then we can write the general term in terms of either n or in terms of the previous term. Say for example, if you're writing the term in terms of n being the number of term that we're talking about. First term means n equal to 1. Second term that we're talking about means n equal to 2. Fifth terms would mean n is equal to 5. So if we are describing the term an in terms of n, then we can write it as, say for example, 2n minus 1 in this case, in the first case. Or we can also write the general term in terms of the previous term being an minus 1, where an is the current term. So an is equal to an minus 2 plus 1, again for the same progression. So this progression can be written in the general term of this progression can be written in two ways. An could be said to be 2n minus 1, where we put n equal to 1, we get an is 1, which is this the first term. Then if we put n is equal to 2, we get 3. If we put n equal to 3, then we get 5. And similarly, if we take this one, and where an minus 1 is defined, here n has to be a minimum of 2, because an minus 1, when n is equal to 2, which is the first term, has to be defined for us. So we are saying if the first term is defined for us and n becomes 2, we can find out the second term by saying the first term plus 2. Right? So similarly, if we are saying, if we take the second sequence, then we can write it as 2 to the power n minus 1. So if we are saying first term, then it becomes 2 to the power 0. Second term, it becomes 2 to the power 1. Third terms, it becomes 2 to the power 2, and so on. Or again, you can also say that we can write it as the previous term, which is a n minus 1 into 2, and the first term will have to be given to us in this case. In this third pattern that we have, we can say this is equal to n square. So an is equal to n square in this case. So if n is 1, it is 1. If it is n is 2, it becomes 2 square, which is 4. If n is 3, it becomes 9, and so on. So this is how we are representing the general term of a progression. Now let's see what is an arithmetic progression. Arithmetic progression is a type of progression in which each term other than the first term is obtained by adding a fixed number to the preceding term. So we are saying, we just said that we can write the general terms in terms of a previous term. So we are saying if the nth term is previous term plus some fixed number, which we represent as d. So if we have something of this type, then it is an arithmetic progression, and obviously in this case the first term will have to be provided to us because we cannot make the consecutive terms without knowing the first term of an AP. So in other words, arithmetic progression is a sequence a1, a2, a3 till an such that a2 is given by a1 plus d, a3 is given by a2 plus d, a4 is a3 plus d, and so on, where d is the constant and it is called the common difference of an arithmetic progression. We can form an arithmetic progression if the first term and the common difference is given to us. So if we know a1, which is generally used as a for an arithmetic progression, and if we know d, which is the common difference, then we can form an AP because we know it starts with a and then we have a plus d, then we have a plus 2d, and so on. So we can form this. The general form of an AP can be written as a plus d, a plus 2d, and so on. So first term of an arithmetic progression is normally denoted by a, the common difference is denoted by d, and the last term is denoted by L. We are talking about an AP which has a fixed number of terms. So the last term will be denoted by L. A sequence is an AP with the common difference d if and only if an plus 1 minus an is equal to d for all values of n, which is 1, 2, 3, 4, and so on. Because if we put n is equal to 1, we get a2 minus a1. That means starting from the difference between the first and the second term, this condition has to be met, and then only the sequence would be an AP. A sequence is an AP if its nth term is a linear expression of n, and in such cases the common difference is the coefficient of n. Now let's see why do we say that. Let's say the sequence is such that an can be written as pn plus q, where p and q are constants. So we are saying an plus 1 will become p into n plus 1 plus q, and we can say an plus 1 minus an will be equal to the common difference d, and that is equal to p into n plus 1 plus q minus pn minus q. So this cancels out, and pn will cancel out this pn and we'll get p. So the common difference is the coefficient of n if the nth term is a linear expression of n. So we know what a linear expression means. an, the nth term is denoted by pn plus q, which means a linear expression in n. The degree of n is 1 in this case on the right hand side. So this becomes the nth term, and if this is the nth term, then the common difference is the coefficient of n. Now let's talk about finite and infinite arithmetic progression. An arithmetic progression which has finite number of terms is called a finite AP, and that's where we said that the last term is denoted by L. So last term of an AP would be possible only if it has finite number of terms. Example 4, 1, minus 2, minus 5, minus 8, minus 11, and that's it. We are not saying that it is continuing. This is where it ends. So this is an AP with fixed finite terms which are 6 in number. An arithmetic progression which does not have finite number of terms, or an AP which has infinite terms, is called an infinite arithmetic progression. An example would be 35, 43, 51, 59, 67, and so on. So we don't say that it has 5 terms or it has 10 terms or it has 20 terms. We say that it continues. So this is an infinite AP. Let's now talk about the general term of an AP. Now this theorem says that let A be the first term and D be the common difference of an AP, then the general term or the nth term of an AP is given by an equal to A plus n minus 1 D. So now we're going to see how we reach at this formula for the nth term or the general term. We know that the first term of an AP is A. This is known to us. So A1 is equal to A, and that is equal to A plus 1 minus 1 into D. It can be written like this. We know that A1 is equal to A, and this can be written in this form. A2 we know is A plus D, and we can write it as A plus 2 minus 1 into D. A3 is A2 plus D, which is A plus B plus D. So it becomes A plus 2D, and it can be written as A plus 3 minus D. 3 minus 1 into D, and so on. So observing this pattern in the sequence, we can conclude that the nth term an is equal to A plus n minus 1 into D. So now friends, let's see how do we find out the nth term of an AP from the end. So we're not talking about the general nth term of an AP. When we say nth term of an AP, we're talking about the nth term from the beginning. But when we're saying nth term of an AP from the end, let's see how do we calculate that. Now again, we say A is the first term and D be the common difference of an AP which has m terms in all. Now when we say nth term of an AP, we are only talking about the finite AP, because infinite AP does not have a last term. It is continuing forever. So this nth term from the end is possible only for the finite APs. So we take the total number of terms of an AP to be m terms. Then the nth term of the AP from the end is given by either this formula A plus m minus 1 into D, or by this formula L minus n minus 1 into D. So where L is the last term of this AP. Let's see how do we reach this. We know that the nth term from the end would be, if there are m terms in all, and we are starting from here, and this is the mth term. So nth term from the end, we are saying these terms are n, including this one, right? So these are n terms. So the terms which are prior to this is m minus n prior to this. So this term that we have to calculate is m minus n plus 1th term from the beginning. So we can simply use the formula that said that nth term from the end is nothing but a m minus n plus 1, which is a plus m minus n plus 1. This is which term we are finding out, minus 1 into d, which gives us a plus m minus n into d. So this is the formula that we can use to find out the nth term from the end. Now we can also say that this is nothing but a plus m minus 1 into d minus n minus 1 into d. We've just separated this. That's it. We've just taken this m minus 1 here and we've taken minus n minus 1 here. So now a plus m minus 1 d is nothing but the last term, which is L, minus n minus 1 into d. Now an important thing here is that d does not necessarily have to be positive. The common difference of an AP can be negative also. So now if we are finding out the nth term from the end, we can actually say that we write the AP in the reverse order and the last term becomes the first term, and then we are finding out the nth term. So essentially becomes the first term gets replaced by L in this case, because we are talking about the AP starting from the opposite end, minus n minus 1 into d. Why minus instead of plus? Because d here has become negative. So we can, just to understand, we can say that this is how we can also arrive at this second formula for finding the nth term of an AP from the end. So we can conclude that the nth term from the end can be found using these two formulas, either a plus m minus 1 into d or L minus n minus 1 into d. So now let's look at the selection of terms in case of an AP. Now if the number of terms of an AP are odd, then we select the terms as a minus d, a and a plus d. The common difference is d, and now if we have, the sum of these three terms are given to us, then the d will cancel out and we'll just have one variable which we can find out very easily if the sum is given. So that is why we take these kind of terms. If we have 5 terms, we'll take a minus 2d, a minus d, a plus d, a plus 2d, and so on. So if we have 7, we'll take it accordingly. We'll start with a minus 3d till a plus 3d, and the common difference remaining d. But if the number of terms of an AP are even, then taking this kind of the terms will not help, because even if we add that, if we have 4 terms, so instead of, if we have these 3 and a plus 2d in addition, then this is not going to help cancelling d. So we select the terms differently. We select the terms as a minus 3d, a minus d, a plus d, and a plus 3d. Now the common difference here becomes 2d. It is not d anymore, it is 2d. But now if we add these, if the sum of this even termed AP is given to us, we know that the d term cancels out and we can find out a. Or if we have 6 terms, then we'll start with a minus 5d till a plus 5d and so on. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.